Hello, fellow ego-cycle riders and EV enthusiasts. I've converted my 2005 ego-cycle LX to a more modern drive system with a hub motor and lithium-ion batteries. It turned out pretty well and was an interesting project, so I thought I'd make a video to share what I discovered along the way in case any of you have an old ego-cycle in your garage and want to do something similar. I'll do this in 4 parts. I'll talk about what I set out to do and why, what I discovered when I went shopping for the parts I would need, what I chose to do and how it all went together, and finally, I'll talk about how it turned out. So, what did I want to do? In the most general sense, I wanted to update my ego-cycle's drivetrain as transparently as possible. A lot has happened in EV technology since these scooters were designed in the late 1990s, and I wanted to take advantage of that. On the other hand, I like my ego-cycle and I wanted to preserve the look and feel of the scooter. Other than the visual change to the rear wheel, I wanted it to remain the peppy, fun alternative transportation it's been for almost 20 years now. More specifically, I wanted to replace the lead-acid batteries. I've put at least 6 sets of lead-acid batteries in my scooter over the past 20 years, and only one has lasted its predicted lifespan. All the others encountered problems that severely reduced the range of the scooter. I'll talk more about what was causing these failures later in the video, but for now, I simply wasn't willing to pay for yet another set of sealed lead-acid batteries and hope they lasted. I've been looking for a lithium-ion battery pack for several years now, but I've never found one that fit within the battery compartment of the Ego and met the substantial peak discharge requirements of the stock drivetrain. I've seen a few photos over the years of Egos that have been converted to lithium-ion batteries. To meet the peak discharge requirements, however, these all had additional batteries strapped to the rear rack and foot deck. I'm not saying there's anything wrong with that approach, it just wasn't the way I wanted to go. I also didn't want to try to make a lithium-ion battery that would fit within the battery compartment. So, if I wanted to get away from the sealed lead-acid batteries, I would also need to modify the drivetrain to something that could use existing lithium-ion batteries. Coincidentally, the increasing popularity of e-bikes over the last decade has made hub motors powered by lithium-ion battery packs widely available and affordable, to the point where I realized this combination would likely yield the result I was after. Beyond that, I was aiming for a top speed of between 20 and 25 miles an hour, a range of about 20 miles. I wanted to retain regenerative braking and keep the stock lights, horn, and turn indicators. I also wanted to turn it on and off with the stock key switch, and I was hoping to do all this for less than $1,000, but more about that later. And finally, I wanted a finished product, one that was the equal of my Ego when it was new and for which parts and support were easily available. I especially didn't want to end up with something resembling my own personal version of Frankenscooter, built from a collection of components I'd purchased from several vendors and required parts and support from around the world every time it stopped working. As you'll see later in the video, this became one of the driving factors in what I eventually decided to do. Before I get started, I wanted to mention that what I'm going to show you is only one of many ways this can be done. As you will discover by the end of the video, the way I chose is a relatively expensive way to modify an Ego. In the end, it cost approximately $2,000. I'm not making this video to promote this as the best or only way to do this, but rather to illustrate the issues I had to work through as I tried to put it together. There are other, less expensive solutions out there, and I'll show you some of them, but many of them will involve working through the same issues I'm going to talk about. So, with those requirements in mind, the next step was to go shopping for parts. The first issue I ran into had to do with the rear dropout width. Most of the hub motors out there are made for rear wheel e-bike conversions and come with a freewheel or gear cluster and are about 135 millimeters wide. My scooter has a dropout spacing of 113 millimeters, which meant a rear hub motor wouldn't fit. I obviously also didn't need the gear cluster since Egos don't have pedals. Luckily, a few manufacturers also make a front hub version of their motors without the freewheel. These hub motors are designed to fit between the front forks of an e-bike and have a dropout spacing of 100 millimeters. This meant that I would need to look for a front hub motor that I would install in the rear wheel of my Ego. Second, I realized I would probably end up with a better result if I was able to purchase the major components as a kit. To avoid the Franken-scooter outcome, I wanted to purchase parts that someone else had already proved could work together. So I narrowed my search to front hub motor kits, and because the Ego uses 20-inch wheels, I added that to my search as well. Things got interesting. From the start, it was clear that I could do this conversion for under $1,000 as I'd hoped. In fact, after searching Amazon for 20-inch front hub e-bike kits, I found that not only could I do this for less than $1,000, I could even do it for less than $500. But when I noticed all the less than the $500 kits had minimal or no support and warranties of 90 days or none at all, I decided that was not going to turn into the reliable and serviceable conversion I was hoping for. Fortunately, there are higher quality kits out there for less than $1,000. Here are a couple of kits I found that meet that price point. Curb e-bike has what appears to be a nice kit for $740. Here's another from Leaf Bike that, when combined with one of their batteries, comes to about $850. I'm sure there are more out there, but when I found this next site, it really turned my head. This is Grin Technologies, a company in Vancouver, British Columbia, Canada, that specializes in DIY e-bike conversions and upgrades to existing e-bikes. They offer a high-quality integrated kits, tech support via email, a robust website full of instructional material and downloadable manuals for the components they build and sell, a YouTube channel with dozens of instructional and demonstration videos, and perhaps most important, off-the-shelf parts that solved all of the trickier aspects of the conversion, like activating and controlling regenerative braking, turning on the brake light when the scooter goes into regenerative braking, getting power to the lights, horn, and turn indicators. They told me how to modify one of their parts so I could retain my existing key switch in the system. They had a simulator that enabled me to experiment with different motor, battery, and controller combinations and predict what range and top speed I could expect and how my converted Ego would climb hills too. I live on a hill, so that was important to me. If I bought these items from Grin as a kit, they would even solder the connection between the battery and the controller, program the controller for my specific motor and battery combination, and bench test the complete package before they shipped it to me to make sure it all worked as intended. Well, needless to say, all these things helped to soothe my Franken-scooter fears. None of the less than $1,000 kits came anywhere near offering such a complete package that I could buy with confidence that it would perform as I hoped. When I priced out a conversion with a suitable Grin front hub motor kit, I discovered it was going to run me close to $1,600, which led me to pause and do a reality check. Did I really want to invest that much money in this conversion? After all, for that amount, I could buy a brand new middle-of-the-market e-bike. On the other hand, the package from Grin offered the prospect of doing everything I wanted with a reasonable assurance that I could continue to enjoy my ego cycle as I always had and keep it going for another 20 years. In the end, I decided I really had no interest in owning a middle-of-the-market e-bike, no matter how much financial sense it made. I like my Ego. I like riding it. I want to keep it on the road. And for everything Grin offered, I was willing to expand my budget and pay the extra amount. So, how did it all go together? Before I walk through this, let me mention that I'll show you my shopping list at the conclusion of the video so you can see what I bought and what other parts were involved. For the historical record, here's a photo of my Ego in its stock configuration before I started the conversion. Here it is with the rear wheel, motor mount, batteries, controller, DC-DC converter, and charger removed. The first step was to bolt down the seat post because in its stock configuration, the seat post bolts into the motor mount. With the motor mount removed, I just bolted it to the foot deck. The new rear wheel went in easily, with the cable on the right side of the scooter facing down so it wouldn't collect rain. It just slid in with the flats on the axle horizontal. As a part of the kit, Grin built this wheel for me with the rim and spokes I specified. Since the axle is a part of the hub motor, I had to install a torque arm on the left side to prevent the axle from working loose under heavy acceleration and regenerative braking. I had to put a slight bend in the arm so it would fit into the bend in the chassis at that point. Next came the battery. As I mentioned earlier, I had troubles with many of the sealed lead-acid battery packs I put in the scooter over the years. I never did a teardown of the batteries to determine exactly what went wrong, but at the top of my list of suspects was potholes, meaning that when I hit a pothole, the resulting shock damaged the internal electrical connections within the batteries, causing one or several cells to either fail or become disconnected. Lithium-ion batteries also have many internal connections, and since my new battery, at over $500, was the single most expensive item in the conversion, I wanted to take some steps that I hoped would prevent the impact of potholes from causing similar damage. To this end, I decided to mount it on rubber shock-absorbing mounts. Conveniently, this also solved another problem. The available space on the bottom of the battery compartment was too short to mount the battery directly to the scooter chassis. By raising it up about an inch for the shock mounts, I was able to get the clearance I needed. As a part of the kit, Grin also modified the battery case so that the controller would fit neatly inside. Because this controller was designed to function in the open air of an e-bike, and I was going to mount it in my scooter's enclosed but ventilated battery compartment, I added a heat sink to the bottom of the controller to more quickly dissipate heat. I don't know if this is strictly necessary, but it seemed a prudent and inexpensive precaution. If you're familiar with e-bikes, you might notice I installed this battery backwards. I did this because the connectors on the controller were at the rear of the battery, and most of the electrical connections I needed to make were at the front of the scooter. This is a 14.5-hour amp-hour battery that, according to Grin's simulator, should give me a range of about 20 miles. Alternately, I could have selected other more expensive batteries with significantly more range, but I live in a small town and I don't need the extra range, so I opted for this one. I mounted the charger on top of the battery with Velcro and zip ties and connected it to the stock charging port. Next, I installed the harness, or super harness as Grin calls it. This was the component that made the finer points of this conversion easy. It has connections for the display, throttle, electrical power to the accessories. It will turn on the brake light when regen is activated, and it can be configured to activate and control regenerative braking in several ways. With the harness in place, I installed the throttle and display. I had to change out the stock throttle to one from Grin. This had to do with how the Grin controller activates and controls regenerative braking. Grin uses a bidirectional throttle. It has a center or neutral position. I roll it toward me to accelerate and roll it forward or away from me to activate regenerative braking. It's progressive, meaning the more I roll it forward, the more regenerative braking is applied. I'll talk more about this when I tell you how everything worked out. I mounted the display on the handlebars and connected it to the harness with an extension cable. Grin's method is to turn the controller on and off with a button on the display. Since I wanted to turn my scooter on and off with a stock key switch, I spliced into the display extension cable and detoured that function to my key switch. This really isn't necessary since the display will allow you to password protect the on-off button. I just did it to preserve a part of the stock configuration I particularly like. Also, with the battery in the battery compartment, I couldn't access the battery on and off switch. I wanted to be able to easily turn my battery on and off, so I also detoured the battery on-off switch to the key switch so that I could turn everything on and off from the same place. I turned the key to the left to only turn on the battery for charging, and I turned the key to the right to turn on both the battery and the controller for riding. The Ego's stock key switch made this pretty easy since I basically used the go far position for the battery and the go fast position for both the battery and the controller. Finally, I connected the new controller and harness to the Ego's existing electrical system. To do this, I had to upgrade my DC-DC converter to handle my new battery voltage. My Ego came from the factory with 12-volt lights, horn, and turn indicators, and used a 24-volt to 12-volt DC converter. My new battery is 52 volts, so I also purchased from Grin a programmable DC-DC converter to step the battery's 52 volts down to 24 volts, and I replaced my light bulbs, horn, and flasher units with 24-volt components. The new DC-DC converter came with Anderson connectors on the input and output wires. Since it had to connect to the male DC barrel connector on the harness, I removed the Anderson connectors from the input side of the new converter and soldered a female DC barrel connector in their place. I then reused these Anderson connectors on my Ego's wiring harness where it connected to the output side of the DC-DC converter. I also had to replace my stock 24-volt brake relay with a 48-volt unit and solder a female DC barrel connector to its input leads because it also had to connect to a male DC barrel connector on the harness. Figuring out how to tie my new controller and harness into my Ego's stock electrical system took a bit of research and head scratching. So if you're considering converting your Ego, I'd recommend checking the wiring diagrams on the Ego website and comparing them to what's in your scooter. Ego changed its electrical systems over the years, so you need to know what you're starting out with to ensure you get all the voltages and polarities right. Also, I hope you noticed I color-coded the connectors with heat shrink tubing so I wouldn't have to remember how it all went together. I plan to ride my Ego for at least another 20 years, and my memory is not getting any better with age. Before I tell you how it came out, here's my full shopping list with all the parts that went into the conversion. The only items missing are a few nuts and bolts and miscellaneous hardware that can be found at any hardware store. From Grin, I ordered the 9C-FH212 Super H kit. Grin offers a number of kits, and you can change them quite a bit to suit your needs. I ordered the FH212 fast configuration. That's the fast winding of the motor. I got the V7 regenerative torque arm, the brake disc that I have a disc brake on the back of my scooter, so I thought I would do it. More about that later. I had them inject the motor with Statorade, which is a cooling oil. There was a front motor extension cable to go from the back wheel to the front of the controller. I ordered the Rim 20 Alex rim for it, the spokes that are listed there. I let Grin build the wheel for me for $45. I ordered the V6 L10 base runner controller. I had them machine the controller mount to fit into the battery pack. I also got the 600C handlebar display, the main 9 super harness, the bidirectional throttle, the 15 amp hour battery, which is actually 14 and a half, and the 4 amp 52 volt charger. Those were all the items that were a part of the kit. From Grin, I also got the adjustable DC-DC converter, an extension cable for the display, an extension cable for the throttle, a programming cable in case I ever want to change the parameters in the controller. I bought a DC barrel jack extension cable and used that to wire up the key switch to the extension cable. And I also got a brake lever. This is needed to program the super harness with the right configurations. Beyond that, I ordered a few other things from Amazon. I ordered the DC barrel connector, the female pigtails, that I used to solder onto the brake relay and DC converter. I got the heat sink, the brake relay itself, a horn, some heat shrink tubing, some zip tie pads for cable management, and I also got the rubber shock mount, the isolation mounts that I use underneath the battery. The stuff from Grin, with shipping and the additional shipping that was required for the lithium-ion battery, came to $1,878, and the orders from Amazon came to about $100, is my memory. So that was my shopping list. So how did it turn out? Here's a photo of the area under the dash showing the new DC-DC converter at the lower left. Next to it at the lower right is the new 48-volt brake relay. Above that is the super harness, and over above that is the original wiring of the scooter, which I have yet to clean up. Here's a photo of the battery compartment showing the battery on its shock mounts and the charger on top of it. I've been riding my converted Ego around town for about 2 weeks now, and I believe I accomplished and possibly exceeded what I set out to do. The scooter's top speed is increased from around 22 miles an hour with the stock drivetrain to I've had it up to 28 miles an hour on level ground. I haven't run the batteries to depletion yet, but my estimations so far indicate it should fall between 20 and 25 miles. It accelerates as well as the original and climbs hills even better than new. It is peppy, which is not a surprise since the scooter is now 35 pounds lighter than before. It's also easier to wheel around when I'm taking it in and out of the garage. One big difference is the regenerative braking. Before, regenerative braking would slow the scooter down, and I would have to bring it to a stop using the handbrakes. The regenerative braking from Grin is so effective, it will bring the scooter to a full stop all by itself, even going downhill. It's quite something. So overall, it does everything my stock scooter did, and some things even better. So what do I not like about it? The biggest issue I had with the new setup had to do with how and where regenerative braking was done. It was too difficult to operate the throttle and its associated regenerative braking while attempting to pull the right side front brake lever at the same time. To fix this, I moved the right or front brake lever to the left-hand side of the handlebar, and I'm considering taking the rear mechanical brake off the scooter altogether. The regenerative braking is so effective, I don't really need a mechanical rear brake. Another issue I should mention is that the throttle is very touchy compared to the stock throttle. It has a short range of motion both ways and requires a practiced hand to operate smoothly. I believe I can reduce the sensitivity of the throttle by changing a parameter in the controller, but for now I seem to be adapting to this, and I expect it to go away with more practice. The last issue concerns the lights on the charger. Because the charger is enclosed in the battery compartment, I can't see when the light tells me that when the battery is fully charged. I could open up the charger and reroute the light, but that would probably void its warranty. So for now, I just opened up the battery compartment when charging, and I'll see if a better long-term solution occurs to me later. Other than that, I'm very satisfied with how it turned out. I fully expect it to go for another 20 years. So that's one way to convert an Ego cycle to a more modern drivetrain. Admittedly, my desire for a reliable, proven drivetrain with adequate support made this a somewhat expensive conversion. With shipping and miscellaneous hardware, it came to about $2,000 US. I hope I've shown There are other less expensive ways to do it. This is just the one I chose for the reasons I've explained. If you have any questions, please ask in the comments and I'll do my best to answer them. And finally, if you need stock ego parts, I got stock ego parts. Let me know in the comments. Thanks for watching, and I hope you enjoyed the video. If you convert your ego, please let us know what you did and how it turned out.